Welcome to the DIY Honda Garage channel. The DTC P2126 indicates an issue with the Accelerator Pedal Position, APP Sensor B, specifically denoted as TP Sensor E. This sensor plays a critical role in the vehicle's throttle control system by relaying the position of the accelerator pedal to the Powertrain Control Module, PCM. The PCM uses this information to determine the appropriate amount of throttle opening and fuel delivery to optimize engine performance and efficiency. An out-of-range error suggests that the voltage readings from the APP sensor B are not within the expected thresholds during operation. Causes for this failure can range from faulty wiring to an issue with the sensor itself. For accurate diagnosis, all associated components and connections should be thoroughly inspected and tested. The location of the APP sensor is typically found on the accelerator pedal assembly, directly linked to the vehicle's throttle control system. The error described by DTC P2126 relates specifically to an irregular output from APP sensor B, also known as TP sensor E. This sensor's function is paramount in how the vehicle interprets the driver's throttle input. Situated directly on the accelerator pedal assembly, it detects how far the pedal is pressed and communicates this to the PCM. The expected voltage range for this sensor is between 0.22 volts and 2.54 volts under proper operational conditions. If readings fall outside this range, the PCM registers this anomaly and triggers the DTC code. Electrical issues or sensor failure are common reasons for this malfunction, which could lead to undesirable driving characteristics or even engine performance issues if not addressed promptly. Several potential causes can lead to the triggering of DTC P2126. A faulty APP sensor B itself is a primary suspect. This could arise due to internal failures or degradation over time. Additionally, issues within the wiring system, such as open or shorted circuits, can also result in the sensor sending erroneous signals to the PCM. Poor connections, whether due to corrosion or loose terminals, can significantly impact the effective communication between the sensor and the PCM. It's crucial to examine both the sensor and associated wiring thoroughly before concluding that the sensor needs replacement, as wiring problems can often mimic sensor failures. When DTC P2126 is triggered, several noticeable symptoms may occur. One of the most common indicators is incorrect throttle response, where the vehicle may hesitate or not accelerate as expected when the accelerator pedal is pressed. Additionally, engine performance may decline, manifesting as reduced acceleration or stalling in severe cases. The check engine light on the dashboard will often illuminate, alerting the driver to the underlying issue. Drivers may also experience an unexpected increase in fuel consumption, as the PCM may struggle to deliver optimal fuel-to-air mixtures due to inaccurate readings from the APP sensor. Awareness of these symptoms can facilitate timely troubleshooting and repairs. In the first troubleshooting step for DTC P2126, the technician should turn the vehicle's ignition to the on position without starting the engine. This allows the use of the Honda Diagnostic System, HDS, to check the current values from APP sensor B. The key is to verify whether the values fall below the specified threshold of 0.22 volts. If the sensor does show values less than this threshold, the failure has been confirmed, and the technician should proceed to the next troubleshooting step. Conversely, if the values are within the expected range, this indicates system functionality and directs the technician to further investigation into potential intermittent failures. In this troubleshooting step, the technician repeats the check on APP sensor B, but this time, the vehicle must be monitored for readings exceeding 2.54 volts. If the reading exceeds this value, it confirms a failure in the sensor, and steps will be taken to rectify this. However, if no failures are detected, it directs the technician to inspect for potential intermittent issues. Checking for poor electrical connections or loose terminals at both the APP sensor and the PCM should be the priority. If there is an onboard snapshot of the DTC recorded, attempting to replicate the failure in the same conditions can lead to fruitful insights. During this phase, the technician will turn off the vehicle, then disconnect the APP sensor's 6P connector. After ensuring the vehicle is off, the technician proceeds to turn the vehicle's ignition to the on position. With the APP sensor disconnected, the voltage needs to be measured between test points defined at the female terminals of the APP sensor 6P connector. Test point 1 corresponds to terminal number 1, and test point 2 applies to terminal number 2 of the sensor. The ideal condition is to obtain a voltage reading of about 5.0 volts. If the voltage reading matches this expectation, it indicates that the circuit is functioning correctly, directing the technician to the next troubleshooting step. If not, further inspection into the wiring and electrical continuity is needed. In this troubleshooting step, the technician begins by ensuring that the vehicle is in the off position and then utilizes the HDS to jump the SCS line, a procedure to secure safe diagnostics, and wait for at least 1 minute. Following this, the technician disconnects the PCM connector A, specifically the 51P connector. The next task involves checking the continuity between designated test points, APP sensor terminal number 3, and a known body ground. For successful troubleshooting, continuity must be established. If continuity is present, it may suggest that there is a short within the APS2 wire, which necessitates further repair work. If continuity is absent, it indicates the APS2 wire is intact, prompting the technician to move forward in the troubleshooting process. This step requires the technician to create a temporary jump using a jumper wire between the APP sensor terminal number 3 and body ground. Following this connection, the technician should recheck continuity between the test points, specifically at the PCM connector A terminal number 38 and body ground. The continuity test aims to verify the integrity of the APS2 wire. If continuity is confirmed, it indicates that the APS2 wiring is functioning correctly, and the technician will proceed to the next step. Conversely, if continuity is not established, this suggests an open circuit in the APS2 wire, necessitating repairs for proper function. In this step, the technician reconnects the PCM connector A, 51P, and removes the jumper wire from the APP sensor 6P connector. With the connections properly in place, the technician is to jump APP sensor terminal number 1 to terminal number 3 with another jumper wire. After completing this, the technician again turns the vehicle to the on mode and checks the APP sensor B values through the HDS. If the APP sensor B values drop below 0.22 V, this points towards the possibility of a fault within the PCM itself or an associated module. The technician must then check authorized service information for recommendations or consider substituting a known good PCM, which may resolve the issue. Step 7 requires turning the vehicle off and jumping the SCS line with the diagnostic tool, allowing for safe testing to occur. Following the SCS jump, the technician disconnects PCM connector A, 51P, and connects a jumper wire between APP sensor terminal number 1 and body ground. This direct connection enables the technician to check the continuity between the wire and the PCM connector terminal number 40. If continuity is confirmed, it indicates that the VCC5 wire is functioning correctly, and troubleshooting can proceed to understanding the DTC codes. In instances where continuity is absent, this reflects an open circuit in the VCC5 wire, which demands immediate repair to uphold system integrity. As part of troubleshooting, the technician once again disconnects the APP sensor's 6P connector and turns the vehicle's ignition to the on position. The technician then measures the voltage between test points 1 and 2, using terminal number 1 at the sensor and terminal number 2 for comparison. For proper functionality, the voltage should ideally be around 5.0 volts. If the voltage reading matches this target, it suggests that the APP sensor is indeed malfunctioning, warranting a replacement of the accelerator pedal module. If the readings indicate failure, it directs the technician to continue troubleshooting by verifying wiring conditions or other potential system failures. In this final troubleshooting step, the technician again turns the ignition to the off position and uses the HDS to jump the SCS line for safety protocols. After waiting, the technician disconnects the PCM connector A, 51P, once more. A jumper wire then connects APP sensor terminal number 2 to body ground. Continuity needs to be verified between this configuration and PCM connector terminal number 39. If continuity is confirmed, this indicates the SG5 wire is functional, allowing the technician to check authorized service information or replace the PCM if necessary. If not, an open circuit in the SG5 line is indicated, prompting required repairs for effective performance. Upon completion of the troubleshooting steps and any necessary repairs, it is essential to conduct a final verification process. This includes conducting voltage checks across the APP sensor and reconfirming that the replacements or repairs executed have reinstated the required functionality to the wiring and components involved. Once the expected voltage ranges are achieved, the technician should clear the DTCs using the HDS and perform a road test under various driving conditions. This will ascertain that all systems are functioning correctly without triggering new faults. A successful completion will restore optimal performance to the accelerator pedal module and related systems. Preventive maintenance is crucial for ensuring the longevity and reliability of the accelerator pedal and sensor systems within the vehicle. Regular inspections of the APP sensor wiring can prevent issues associated with wear or damage, which may lead to DTC triggers. Ensuring that all electrical connections are clean and free of corrosion will also foster robust performance and prevent intermittent failures that can compromise vehicle safety and functionality. Regularly checking diagnostics using the HDS can help identify potential problems before they escalate, enabling timely interventions. Consistent maintenance not only extends the life of the sensor systems, but also contributes to overall vehicle performance and driver satisfaction. In conclusion, DTC P2126 highlights a significant concern regarding the APP Sensor B's operation within the throttle control circuit of the Honda CRV from 2017 to 2022. Accurate diagnosis is vital to determine the root causes, whether they stem from sensor failures, wiring issues, or connection problems. Each step of the troubleshooting process builds upon careful measurements and inspections to confirm integrity across the electrical systems involved. The importance of preventive maintenance cannot be overstated, as it plays a pivotal role in forestalling issues before they materialize. By adopting a proactive approach and adhering to the diagnostic guidelines, technicians can effectively manage performance concerns and maintain vehicle reliability. Please like and subscribe to the channel. See you next time.